Welcome to Digital Electronics. Today we are going to be learning about K-mapping. The actual name instead of K-mapping is Carnot mapping. So K-mapping is another way or an alternative way of simplifying logic equations instead of using Boolean algebra. Let's begin by doing a quick recap of Boolean algebra. So if we had, let's say, a problem that had a truth table, a very simple truth table, excuse me, that had the following outputs for the input combination. So let's say the truth table was as follows. In the old method, not old method, I should say, in the original method that we learned, which was Boolean, we would say that the minterm equation was this minterm and that minterm or together. So that would be not A, not B, and this one is A, not B. So the minterm equation would then be X is not A, not B, or A, not B. Once you have your minterm equation, which is just where all the ones in the truth table are at an output, then you OR them together. So that's not simplified whatsoever. Using the laws of Boolean, we would then notice that they both have the not B letter in common. We would use the commutative or the distributive property to factor that not B outside of the parentheses. Inside of the parentheses, we would have the not A from the first term and the A from the second term. Then we use the opposites through an OR gate theorem to simplify this to a 1. So then we would have not B ANDed with a 1. And we again use the theorem of an AND gate with a 1. It just simplifies to not B. Now, instead of using Boolean in that sense, we're not going to be doing that anymore. We're not going to be doing Boolean anymore. However, I want to point out that there's this very specific property that happens all the time, or I guess theorem that happens, that if you have opposites through an OR gate, it becomes a 1. It's always a 1. So that's going to be a really important thing to remember when we're doing K-mapping. So K-mapping, instead of having a list as we have in the truth table, what we're going to do is we're going to take this truth table and we're going to make it a map. Now, some people say that this is comparable or similar to Punnett squares from science class, where you have a row is one combination and a column is another one. So, and it is kind of similar, but I guess we use it for different purposes after this. So here we have on the left, we're going to have where an A is 0, A is a 1 in the bottom row, B is a 0, and B is a 1. Now, some people write the K-map. Instead of putting the A and B, they put A here, B, and they say 0, 1, 0, 1. That's another way to do it, but we're not going to follow that convention. We're going to follow the convention on the left. So, but sometimes you'll see some text like that. So what does this mean? It means that, for example, we're going to have this entire row is where A is a 0. This entire row down at the bottom, remember rows are horizontal. The entire row at the bottom is where A is a 1. The left column is where B is a 0. And the right column is where B is a 1. And I could put the A and B on the other side, where I could put the A's on top and the B's on the side. But just to keep things flowing so that we all do it the same so that we can help each other, we usually start on the left variables, the first letters on the left and the second ones on the top. Also, we could also do where we could put A and put the not A at the bottom and the not B on the right. But again, just to keep things same for all of us, we'll start with the off first and then the ons. So let's all standardize it in this class so that we all keep them the same way. So with this K-map, now what we're going to do is we're going to fill it in. Let me redraw it because I drew all over it again. So I'm going to draw a blank one without those rows and columns highlighted. So this is my K-map and it's blank. So what we're going to do is we are going to fill it in. So I'm going to take my Boolean simplification and move it out of the way. And I'm going to take my blank K-map and put it right next to my truth table so that I can fill it in. Okay, so now what we're going to do is we're going to put all the ones and zeros inside of the K-map. So here we go. Let's get started. I'm going to talk about this one first right here. This one right there. That is the combination where A and B are both off. So that would be where A is off and B is off. So where the column for A being off and B is off intersect. And that's the top left location. So what we do is we put whatever's value, we're going to put it in there. So that happens to be a 1. Then the second combination is where A is a 0 and B is a 1. So that is still the top row, but now the right column. So the answer for that is whatever the output is, which is a 0. And then the next combination on the row is where A is on, which is now the bottom row, and B is off, which is the left column. So you go down the row placing that now instead of a list, now you have a map where the combination becomes a location on the map. And that's how you fill in the K-maps, right? Let me tell you if you had several variable sizes, and then we come back to this one. So here, as you saw, you have the K-maps where you have the location becomes each combination. I will tell you that if you follow the pattern where we have the first the zeros and then the ones and the first letters on the left and on the right, you will have that one going to that location, this one in this location, the next one would be there. Oh, I don't know why that one's thicker. Well, anyway, and the next one going to this location and the last one going to that location. That's for a 4 variable K-map. Now, I mean, not 4 variable, 2 variable K-map with 2 letters. Then what you do for the K-map is, these are the K-map steps or equation extraction steps. Because that's the whole point, right? To get the simplified equation. So what you're going to do to get the equation is, number one, is you're going to group adjacent ones. Now, it's very important that you understand the word adjacent. Adjacent means that they're next to each other, right? Like if you have a 1 and a 1 like that, or if you have a 1 and a 1 like that, or if you have ones like that, etc. So they're all touching. The thing to understand is that there's valid group sizes. You cannot, because of this adjacency rule, you cannot have groups of 3 because that would be a weird shape. It has to always be a quadrilateral. So you can have, sometimes there's no grouping other than 1, but so the valid group sizes are 16, 8, 4, 2, or 1. And you should notice basically that is 2 to the n, where n is an integer. So that's something to remember. You can only group groups of 1, 2, 4, 8, 16, etc. Notice that it's not 6 is not a valid group, 3 is not a valid group. So if you're grouping adjacent ones, let's say you have 3 like this, that is not a valid group. Or like if you have, and this is when we get to bigger K-maps, of course, you probably, like you can have 6 like that, and that is not a valid group. It has to be these valid group sizes. Okay, the next thing to remember is that bigger is better. Bigger groups are better. So if you can make a group of 4 or a group of 8, 8 is better than 4. And I'll show you some examples. The other one is that overlap is okay. Overlap overlap is fine. So sometimes you're going to have, it's kind of like if you think about a Venn diagram, sometimes you're going to be doing a grouping and then you're going to have another grouping that kind of overlaps with it a little bit. That's fine. Don't worry about that. It's as long as you don't have like one group inside of another one. And lastly, fewer groups is better because that's going to give you a simplified equation, more simplified equation. Oh, I guess lastly I should tell you is that opposites cancel. So that is the theorem that it says if you have x or not x equals 1, right? They cancel to 1. That's what I mean. All right. So that's how you get the equation out. So let's practice on this one that I just drew on the first one. So again, going back to my previous example, we have our truth table that we translated into a K-map based on the locations. So now what we're going to do is we're going to look for grouping. So look at the steps. Step 1, group adjacent ones. And I do see these two adjacent ones next to each other right there. Very good. Is step number 2 is the bigger group is the better. Well, yeah, I could have grouped 2 groups of 1, but that's not better. What bigger groups is better. Overlap is fine. Well, here in this case, we don't have any overlap because it's only one group. And then fewer groups, there's only one, and opposites cancel. So what do I mean by that? This part, here, let me use my little lasso tool to demonstrate. Okay, so as you can see right here, there's the grouping. So what you're going to do is you're going to look to the left and you're going to look up. And if the variables that the grouping overlaps are opposite, you just don't write them down because they cancel to 1, and anything ended with a 1 is the other variable. So look here and you move it to the left and see how the grouping overlaps both the not A as well as the A. So it basically, what this is saying is that in that grouping, it doesn't matter if A is off or if it's on. They cancel. That one doesn't matter. However, if you look up, it must be in the not B section. So this grouping right here, you look to the left and you look up, and opposites will cancel. So that one cancels, goes away. You just don't write it down. And you look up, that one stays. So here we go. On that one, what you're going to do is the grouping. Oh, what did I do? I canceled. So the equation for that grouping is just not B because the grouping going to the left canceled. And that's it. That's my equation. So the output for this one, x, is not B, which as you can see matches what we did with Boolean algebra, but in a faster step. Well, it took us longer because I was explaining the steps. Let me give you a different example. Okay. Let me move this up a little bit or to the side a little bit. Let me work here on the right. So let me do a different example. So let's say I gave you a different truth table. I'm going to use the same letters because it's easy, but it doesn't have to be. So let's say I gave you that example. Well, let's build the K-map. Label it. Again, you can label it in whatever order, but let's stick to a pattern so that we all do it the same. So not A and A, the first variable on the left, and the 0 first, and then the second variable on the right, and the 0 first, not B first. Okay, so let's place the variables in the correct location. This first variable right here is where A and B are both not A, not B, or both off. So that is this row and that column. So we put a 0 in there because that's what the value is. The next row is where A is 0 and B is a 1. Therefore, that's the top row, right column, and that's a 0. Then the next combination right here is where A is a 1, so that's the bottom row, and B is a 0, so that's the left column. And now that's a 1 because that's what my output on my truth table is right there. And the last combination is when they're both 1, so bottom row, right column, and we put a 1 right there. All right, so let's do the equation step. Look for groupings that are um, valid group sizes. So the bigger the better. And as you can see, yep, I have these two ones adjacent to each other down at the bottom. All right. I'm going to use my little magic glasses so I could do the motion, and you can imagine you could float the group. So then this is the biggest group, and that's the fewest group I can make it. You look left, and then you look up, and you look at the overlap. As you can see, the group, if you group to the left, it only overlaps A. So that one doesn't cancel. If you look up, it overlaps both the not B as well as the B. So these two cancel and the A stays. So the equation for this grouping is then just A. Whatever variable it overlaps stays, but if they're opposites, they cancel. So that's my equation. X is just A. Sometimes, let me give you another example. Sometimes no simplification happens, and that's okay. Let me just show you what that would look like. Like if I had this equation, and later we'll learn that's actually an exclusive gate. But if we have, again, following the same pattern, if you follow the same pattern, it becomes actually quite easy to fill in the K-maps because you generate a pattern of how to fill them in. So the first combination is a 1, which goes right at the top, not A, not B. And let me just put in the ones because I don't have to worry, and then fill in the zeros, right? So the last combination is when they're both 1, 1, that's down here, and the other two are zeros. Okay, so here we're going to look for groupings of 1. As you can see, they're not adjacent. Diagonal like that is not sharing a side, so that's not adjacent. So we're going to have to resort to the smallest group, which is a group of 1, which is right there. And we have to capture all the ones, so the second grouping is right there. So that what we do is we look at the grouping in green right there, and we look up and we look to the left, right? So if you look this way, it does not overlap opposites. If you look up, it does not overlap opposites. So the equation for that one is not A and not B, and nothing cancels on that one. If you look at this orange grouping, you look to the left, it doesn't overlap opposites, and if you look up, it does not overlap opposites. So the equation for that is A and B. So the final equation for it is the green grouping or the orange grouping. And it doesn't matter, you can do orange or green. But it would be not A, not B, or AB. And later we're going to learn that this was the XNOR gate. But for now, that's the most simplified you can get. So what we've learned so far is that the grouping, that's why the bigger is better, because the bigger the group, the more things that cancel. For example, you notice here in this top pink grouping, we circled 2 and it overlapped. The B's canceled. When we circle 1, nothing cancels. Sometimes, I don't know why you would do this, but you could. Another example would be if you have a truth table where everything is 1. Like you wouldn't even have to K-map it, right? Like you know that the equation says that the output's always going to be on. So just connect the output directly to power. But let's say you had a brain fart and you wanted to still K-map it. So I don't even have to look at the pattern. They're all ones, right? So if we group them, you can group 4, which is a valid group size. And by grouping 4, you realize that to the left, it overlaps both, so they both cancel. And to the right, to the top, it overlaps both, so so everything cancels. So X is always just 1, right? But again, I wouldn't build the K-map like that because I could see right away from the beginning that it's always on. But if you wanted to, everything would just cancel. And the same thing would be for 0. If the entire truth table is all just zeros, it's always off. You wouldn't even have to do a K-map nor Boolean. It's always just off. Okay, so that's how you do a K-map when you have 2 variables. But what happens if you have 3 letters like A, B, C, or 3 variables? So let's say I have a K-map that has, not a K-map, a problem that I'm trying to, or a circuit that I'm trying to design. So that's 3, 4, 5. Yep, I hope I didn't miss any. Yeah. So let's say I have this combination right there. And let's say I had the following outputs. I had 0, 1, 1, 1. I'm going to put a little line here so I don't go cross-eyed. 0, 1, 1, 1, and then 1, 1, and then another 0, 1. Let's say I had that for my 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 equation, my truth table. Sorry. Okay. So how in the world do I build a K-map? Well, when you have 3 letters, you're going to have as many locations as there are coming in. So I need 8 squares. So when you have 8 squares, you could do it vertical like that, or you could do it horizontal like that. Either way is correct, but so that we do it all the same, we're going to do them vertical just to keep them the same. Okay, but it doesn't matter. You can do them either way. Also, you could put the letters A and on the top and B and C on the side, but just to keep it the same, we're going to put A on the side. We're going to start on the left and then go up. Okay, now it's super important for you to realize how we're going to place this. So this first thing is not going to work out. Watch out. Look it up. Look how it works. So you may be thinking, put A, not A, not B, B, and not C and C. However, that's not going to yield a location for every combination because check it out. Where is the location where A is 0, B is 0, and C is 0? That would be A is 0, B is 0, and C is 0. So they don't all intersect at once. So that is not the correct way of labeling my K-map. Some people may say, okay, well, I can put the A on the left and the B on the right. So I can put A, not A, B, no, sorry, A, not A, and then not B, and then B on the right. You could do that, but it's kind of difficult to look left and right. So there would be not A, not B, which one? And so instead of doing it like that, that can get a little confusing. So what we're going to do is we're going to combine letters on the left, and that is how most texts do it. So we're going to make it not A, not B. So we're just going to have a pattern that follows the combination. Now, we have not going over binary numbers and counting, but this is very similar to that. And then we have A, B, and A, not B. So I want to really, really emphasize something. The pattern that I just chose right here, I want to highlight the fact that the first 2 are 0, 0, or not A, not B. This one is 0, 1. And then you have both ones, and then you have only the last one. So the trick here, or the rule, is that when you go from one row to the next and from one row to the next, only one variable can change at a time. So from here to here, notice that the A stays as not A, and the B becomes opposites. For the next change from here to here, the B stays the same and the A are opposite. And from here to here, from the last 2 rows, the A is the same and the B is opposite. And lastly, from here to here, all around, the B is the same and the A is opposite. So that is a must. You could change the pattern to have, as long as one is the same and one is opposite. So you could really shift everything up and put that one to the bottom. But again, just so that we all keep the same order, we're going to follow that pattern. So basically, it's the inverter goes on the first 3 and the last one. Okay. Following that pattern, you're going to see that this first combination that I have highlighted in yellow is where all 3 are off. So that's that combination right there. Right? Let me highlight this one so that we can all agree that that's where the not column is. So we're going to fill it in. So that 0 goes right there. You know what? Since there's only 2 zeros, let's fill in the other location for the 0. So that one right here is where their A and B are both 1, which is this row, and C is a 0, which is this column right here on the left, right? So that's a 0. Wait, I put it in the wrong place, right there. And then the rest are 1s. Uh, so that one's a 1, right? This third one is also a 1. The next one is also a 1. I just want to point out something that's super important. Because our pattern on the left is not in binary order, we actually flip these two columns. As you fill in the Kmap, you'll notice that you will have this one right here actually skips the third row and it goes to the bottom. And because that's where A is on and B and C are off. And this one right here is down here as well. And the last one goes right there. So if you were to follow this pattern, it would be, um, the way that you fill it in, it would be 1, 2, 3, 4, 5, 6, 7, 8. It would skip the third row and come back. It would be here, here, and then here. So that's how it would work. I don't know if that arrow made sense, but it would go from here to here, then from here to here, and then from here to here. All right. So now that we have our K-map filled out, let's look for groupings. So adjacent ones, do you see adjacent ones? And remember, bigger is better. And then you just look for what cancels. So as you can see here, I can see a group of adjacent ones in this entire vertical column. And look, I captured most of the ones already. If I look at this one right here, I can group it in a group of 2. And overlap is fine as long as it's not like one inside of the other. And this last one, I can group it right there. Now, if we look at the equation for this green circle that we grouped, if we look it to the left, it overlaps all the letters. So it actually overlaps B, not B. And so it's 2 pairs of not B as well as B, as well as the not A and the A. So the green bubble or the green grouping overlaps everything on the left and everything cancels. But if you look up, it overlaps just C and that one doesn't cancel. So that stays as C. On the pink grouping right here, you look to the left, nothing cancels. So that one is not A, B. And you look up and the pink grouping overlaps both the C, so that one cancels. For the blue grouping down here, you look to the left, it overlaps only those letters and it does not cancel. So you write them both. And you look up and the blue overlaps both of them of the C, so those cancel. So my equation is just the green or the pink or the blue. And it doesn't matter, I guess. You could, I'm just writing it bottom up. So then not A, B, or C. Sometimes it's easier to write them alphabetical, but so there you have it. That's how you would get the equation for this K-map. I want to show you a trick that happens with this K-maps though. Sometimes if you have a circuit that has some ones at the top and the bottom, you could wrap around. So let me show you how that would look like. 1, 1, 0, 1, 1, 1. So let's say I had the equation where we had 3 1s, a 0, 2 1s, and 2 zeros. Okay, so let's fill this K-map. So here, again, let's follow all the same pattern. There's lots of different ways to organize it, but let's follow the pattern. So I'm going to put A, B on the side. And it's the first 3 and the last one. And then C, like that. So let's fill it in. Let's put the zeros in the right place so that then, because there's fewer zeros than ones. And so this 0 right there, it's where it's not A, yes B, yes C. So that's not A, that's the second row. BC, that's right there, right? The next 0 where we have, again, I'm placing the zeros because there's fewer of them, and then I'm filling the remaining in ones. So the second 0 is where A and B are both 1, so that's the third row, and the C is 0, so that's the left column. That's right there. And the last one is where all variables are 1. So AB is a 1 and C, so right there. Hopefully I put them in the right place and the rest are ones, right? Okay. Now that we filled it in, the groupings are always, we ignore the zeros, but I guess I don't want to confuse you. I put the zeros in the right place only because there was fewer of them to fill in the Kmap, but we ignore the zeros after this point. We only focus on the ones. So let's, for the groupings. So for the groupings, do you see groups of adjacent ones? And most people would see this and be like, yeah, there's one group here and one group at the bottom. However, I would like to tell you that think of a K-map as a like a wraparound. Like if you have ever seen or played Pac-Man, you know how Pac-Man goes in one side and comes back the other. So here you could think about this grouping as if it wraps around from the top to the bottom. Yeah, so in that case, that would be one grouping of four, which was bigger rather than two groups of two. So remember the rules, fewer groups is better, and bigger groups are better. So in this case, we did both, one bigger group instead of two smaller. And then there is another grouping because I still haven't captured this one. And some people are like, oh, I could do three going around this way. But nope, three is not a valid group size, remember. Only two is a valid group size for that size. All right, so now that we have our groupings, let's look at the overlap. So this pink grouping, if you look to the left, it cancels the A's because it overlaps opposites, but the not B stays. And if you look up, the red grouping cancels the C's as well. The blue grouping, if you look to the left, it cancels the B's, but the not A stays. And you look up, the not C stays. So again, look at the overlap. If they're opposites in the overlap, you just don't write them down. So my equation is not AC or not B. So there you have it. Hopefully you can see that the process. Now, one last one in three variables. Let's say you had this truth table. Oh, I don't know why I wrote it so long. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 0, 1, 1, 1, 0. Let's say we had the following. We had a 0 and then all ones. So if we did our K-map like this, we label it always following this pattern. Again, it doesn't have to be, but for our group, so that we can all get along and can compare our work, we can follow that pattern. So the first combination is we're all 0, which is right there, and the rest are 1, right? 1, 1, 1, 1, 1, and 1, 1. So now look for groupings. The bigger grouping, the better. Hopefully you see the vertical grouping that we did before, right? You look to the left and you notice that everything cancels for that group, and you look up and this grouping is just a C. For this reddish pinking grouping, so now we have these 3 ones here, but again, I cannot circle 3 and I cannot circle 6. My valid group sizes are 16, 8, 4, 2, and 1. So here I cannot circle 6, but if I think about it, I can circle these 2 and overlap a little bit right there. That grouping in pinkish red, if you look to the left, the B's cancel, right? So we keep A. If you look up, the C's cancel. So that grouping is just represented by A. Lastly, here we have a 1 here by itself, and the biggest grouping, you may be thinking, oh, look, I can circle 2. No, bigger. I can circle 4. It's overlapping is okay as long as it's not one circle inside of another. So yes, that grouping is the best, biggest grouping. So by circling like this, that would be the biggest grouping you could make. So now, if you look to the left, the yellow circle cancels the A. So this is B, and the yellow circle cancels the C. So it's just B. So my equation for this one is just A or B or C. Now, one trick I want to show you on this one is instead of here, I'll use like the magic rainbow color. Some people were like, well, instead of circling all the ones, there's only one zero. Can I just circle the zero and say my answer is not that one? The answer is yes. So an option would have been circle this one, and you look, it does not simplify. So my equation x is equal to not A, not B, not C, not, like not that, because um, yeah, because it's not that. That's where the zero is. And then you could simply use De Morgan's, where you break the line, change the sign at those places, and it would be not A, not B, not C, and then the big line breaks into three, and the multiplication becomes OR. And then the double inverters just cancel, because a double inverter is like if it was nothing there, so it would become A or B or C. So as long as you know how to use De Morgan's, sometimes it may be simpler to circle the zeros instead of circling all the ones. That's a little shortcut that you should know about. Okay, let's move on to 4-variable K-maps. Sometimes you have 4 letters. This one, give me a second because I have to fill in all the, so I know I'm going to have 16 combinations, 0, 1, 0, 1, and I'm just going to divide it into groups of 4 so that I don't go as crooked, because I know I'm still going to go crooked. There you go. And then 2 zeros, 2 ones, 2 zeros, 2 ones, and then 4 zeros, 4 ones, 4 zeros, and 4 ones, and then 8 zeros and 8 ones. Okay, so to fill in this K-map, before I fill it in with give you an example, I'm going to tell you that there's the same pattern on the left and on the top. So again, we're going to put AB on the left, and we're going to put the first 3 and the last one. And CD on the top, and it's the first 3 and the last one. So you should be aware that the pattern is going to be the same as we're filling it in. Let me highlight how it's kind of filled in. So the reason I divide these sections into 4 is because I want you to notice that this section right here that I've highlighted in pink is where A and B are both 0, right? So that's going to be this entire row right there. And then it's a matter of following the correct order. So C and D 0, both off, that's going to go right there. Or actually, not the combination. Whatever the answer is here at the output is going to belong in there. The next one is where C is 0 and D is a 1, which is right there in that column. The next combination is with C is a 1 and D is a 0, which, see how it skips the third one, it goes to the fourth? That's the same thing that happens going downwards. And lastly, well, let me change the color to, what don't I have? Blue, I already have blue, pink, yellow. So the last combination here would go where C and D are both 1. So notice how it goes 1, 1, 2, 3, 4. So it kind of skips the third combination. And that's going to be the same thing in the next section where I have, let me highlight it in green, let's say. So this next section of combinations is where A is off and D is on. Sorry, B is on. A is off and B is on. So that's this section right here. And it's going to follow the same pattern. 1, 2, 3, 4, like that. And the same thing's going to happen going downwards. Now, notice here, A is on and B is off. So that's down here. See? And then it's going to go 1, 2, 3, 4, like that. And lastly, we have where A and B are both 1. So filling in the K-maps is going to be in those 2, I mean, those 4 are in this 4 row right there. So notice it goes, in the sections, it goes 1, 2, 3, 4. And filling in the numbers, it goes 1, 2, 3, 4. So it always goes to the fourth, and because of this adjacency pattern that we have here, where only one letter can change at a time. Okay, so that's how you fill it in. We'll have plenty of practice filling them in, but now I want to show you how would you group them if you had a Kmap filled in. So let's pretend that we went through the process and filled it in and put it in the right place. And let's say we had this Kmap, AB, 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 the first three and the last, CD, the first three and the last. And so let's say we had a situation. I want to show you how, I guess two, because you'll get plenty of practice. But let's say you had ones like this. Yeah, sure, why not? So if you had a one like that, how would you group it? So here, I remember my valid group sizes are 16. I keep writing with a highlighter. 8, 4, 2, and 1. So here, do you see? Oh, wait, don't forget there's also zeros there. I mean, yes, you don't have to draw them, but whatever. So here, as you could see, you could group all 8 in the center, right? And if you group all 8 in the center, if you look to the left, 2 A's cancel with 2 not A's, and 2 not B's cancel with a B. So the vertical, anytime it spans the entire vertical section or the entire horizontal section, everything on that section cancels. But if you look up at this grouping, the C's cancels, but the D stays. So this grouping is just D. And the other grouping that we can make is we can make this entire section right there in the center. Remember, bigger is better and overlapping is okay. So if you look up to the top, everything cancels. See how it overlaps? There's 2 not C's with 2 C's and 2 not D's with 2 D's. And then to the left, there's A and not A. So this is just B. So the equation for this one, whatever it is, let's call it X, is B or D. I just want to show you examples of the possible ways that you could group things. So another way that you could have it is you could have, oh, this one's a cool one. So if you have those ones, oh, let's say you had this, like ones all around. I don't know, I'm just making it up so that you practice. So the way I would group those, let me label them so that we can get the equation as well. So the first 3 and the last one, the first 3 and the last one. So the way I would group those is you take the top row. Remember that Pac-Man trick? That one works all over. So here it would be the left, the A's cancel, and it's not B. And then the top, it overlaps all of them, so they all cancel. And then we still have to group the other ones that are there. Let's group these. You could do these 4, but no, bigger is better. You should do all 8 like this. And those, again, the entire thing cancels on the left, and the C's cancel, so this is just not D. So the equation for this is not B or not D. You can use the Morgans, I guess, on this one. One last one before we do a quick recap. So let's say I have a K-map that has just the 4 corners on, or 4 corners in the middle, I guess, and the rest are off. So what can happen is, here, let me label it. I can't think and chew gum at the same time. So the first 3 and the last one, CD, the first 3 and the last one. So you may be thinking, well, this first group of circle, that's true. That could be the first one. And that one, the A's cancel, the B stays, the C's cancel, and the C's. So this is B and D. For the next grouping, you may be thinking, well, I could group this one from side to side. However, you could also do it this one from top and bottom. The trick on this one, this is the only time that it happens, that you actually can group the 4 corners together like that. Think about it as wrapping sideways and vertically and horizontally. So if you look on this one, if you look to the left, the overlap, the A's cancel, the not B stays, and then if you look up, the C's cancel and the not D stays. So this one is BD or not B, not D, which is another one of the exclusive gates that we're going to learn a little bit later. So there you have it. You have, let me recap what we did on the lesson. So K-mapping is another technique for simplifying equations. You build the K-map following the pattern where you have adjacents, only one letter changing at a time. If you have two variables, you just put the letters on the side. And again, you could do it whichever way, but we're going to put the first letter on the left and the second on the top. Okay, place the ones in the correct place, ones and zeros. And then to get the equation, you group adjacent ones in groups of 16, 8, 4, 2, and 1. Bigger groups is better, overlap is fine, as fewest group is better. Now when the grouping, that's the part that you need to practice, but that only practice is going to help you get it. But once it clicks, it clicks. The overlap, you imagine you can float the bubble to the left and you float it up. If the bubble overlaps both positive and negative, if you would, you just don't write them. And you follow the pattern, like I said, it goes 1, 2, 3, and then it skips down. So let me plug in my battery. There you go. So now you have the three variables. You could do it different ways, but we're going to do it vertically, where the A and B on the left and the C on the top. And if you have four variables, you have A and B on the left and C and D on the top. There's one last thing I should mention, and that is sometimes you have a condition called a don't care condition. So let's say you have a circuit where the output doesn't matter if it's on or off. So let's say I'll do it a three variable so that it's not too simple or too difficult. So let's say we have a situation where we have 0, 0, 0, 0, 0, 1, 1, 0. Okay, so let's say we have that situation, right? And this one is going to translate to a K-map. So AB, the first three and the last one. Okay, so let's say we have a situation where we have these two are 1, which would translate to this 2 are 1. Let's say this situation right here was 0. This situation was also 0, so those are both zeros. The next situation was this one is the one where it's like, you know what, I don't care if it's a 1 or a 0. And this one, I don't care if it's a 1 or a 0. So the output can be on or off, it doesn't matter. So that one would be there and that one would be there. So you just, X means it doesn't matter if it's 1 or 0. And the last one is, this is a 1 and this one is a 0. So that's a 1 and this is a 0. Let's say that that's what you had. And it doesn't matter if you, what's it called? This is just an example. Okay, so the way to treat the X's is if it helps you group in a bigger way, you should group them. If not, you ignore it. So in this situation, these X's could be grouped in this way, like that, and that would make a bigger grouping rather than just grouping these two together. And that means that I would have a smaller equation. So for this situation, I would make the X, these two, treat them as ones. And also, it would help me group this one like that, right? So that X actually helped me twice. In some situations, like let's say you have, here we have another location situation where let's say you had a 1 there, 0, 0, X. No, wait. I was trying to do something similar. So 0, 0, let's say you had 1, 0, and X, right? So you just had that one right there instead. So if you have this situation, I would group this one like this and then ignore that X. So in the situation on the left, hold on, let me finish writing AB, 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 A not B. Okay, so on the situation here, this one, which is the one that I built the truth table, my equation would be for the pink, it would be the C's would cancel, the A's cancel, so that's not B. And then for the blue one, the B's council, it's A, and then the top is not C. So this is B, not B, oh, not B, or A, not C, right, for that one. On this one, my equation is just the blue one because I didn't have the ones on top to actually group. So the equation, the B's council, and so it's just A. So now, notice how the x's, they were in the same place, but depending on the situation on the left, the x's both help me to group the other ones bigger. On the situation on the right, this x on the left helped me make this one grouping bigger, but this one on the right, I'm not going to group it because it's not going to help me in any way. So the x's, you treat them however they're going to benefit you the most. If they help you make another group of ones bigger, you treat it as a 1. If they don't, you just treat it as a 0. Don't just go circling x's to treat them as 1s, because if I were to circle, like let's say I were to circle this one right here, like I would probably circle like that, I'm going to make my equation longer. And that's not the point. The point is to make the equation shorter. So there you have it. That's the don't care conditions. You treat them however they most benefit you. So I hope that was helpful. That's a short summary of Kmapping. Uh, Hopefully that was helpful, and we'll see you next time. Ta-da for now. That's it.